To solve this question, we first need the distance of sun from the earth, and this can be calculated by assuming that the earth is rotating about the sun in circular orbits. The required centripetal force will be mv square by r equals to the gravitational force between sun and earth, which is gm into ms divided by r square, where r is the distance of sun from the earth and m is the mass of earth. So from this, v square can be calculated as g ms upon r. Now if the earth is rotating about the earth in the circle of radius r, then v can be written as v equals to 2 pi r divided by t, where t is the time period. Squaring on both sides, this can be written as v square is equals to 4 pi square r square divided by t square. So equating the two equations, gms divided by r equals to 4 pi square r square divided by t square. From that expression, r turns out to be gms t square divided by 4 pi square raised to the power 1 by 3. So putting the values, one can get r equals to 6.67 10 to the minus 11, and mass of sun from the table given is 1.988 10 to the 30 into the time period of earth revolution is 365 days. That means 365 into 24 into 60 into 60 squared divided by 4 pi square whole to the power 1 upon 3, and r turns out to be 1.4948 into 10 to the power 11 meters, and this is the required distance of the earth to the sun. If theta is the angle subtended by the sun on the sky, that is on the earth, then theta can be written as d by r, where d equals to the diameter of the sun. Now it was given that the sun is subtending in an angle of 0.5 degree on the sky, then the diameter can be written as theta times r. So theta will be equals to 0.5 degree, and that is to be converted into radian by multiplying by pi divided by 180 into the value of r was found to be 1.4948 10 to the power 11, and this comes out to be 1.3045 into 10 to the power 9 meter. So the radius of sun will be d by 2, and that turns out to be 6.5225 into 10 to the power 8 meters. Once we find the radius of sun, the calculation of volume is easy. The volume will be equals to 4 by 3 pi r cube, and if we put the value of radius of the sun in this expression, 4 by 3 pi 6.5225 10 to the 8 cube, and that will be equal to 1.16234 10 to the power 27. So the density will be equals to the mass divided by volume, and the mass of the sun was given in the table 1.988 10 to the 30 divided by 1.16 into 10 to the power 27, and the density comes out to be 1.71 into 10 to the power 3. Unit is kilogram per meter cube, and that's the answer. Thank you.